Today is Monday, August 22nd, 2022. It is also day 400 of data science. And I'm honestly just going to practice what I learned yesterday because, yeah. So, yesterday I generated data um, from a normal distribution. I sampled, right, from a normal distribution. So, I'll do that today as well. And then I'll practice converting it into a data frame just like I did yesterday. It's just practice. So, yeah, I'll import NumPy as NP and then my x values, my y values, and then what I'll do is I'll do np dot random dot normal, and then that takes in three parameters. So it takes in my loc, my scale, which is my standard deviation, and then the size of like the array that I want. So for me, yesterday I did 0.5 for the mean, so today I might do like, I don't know. Let me search up a Khan Academy. Hold up, Khan Academy area above a curve, above a point. Let's see. They usually give good examples. All right, so I'm gonna say that my mean is 23.5 and I have a standard deviation of 2. So my mean, I'll actually set up my variables here. So standard deviation 2 and mean 23.5. That's what it was, right? Okay. It's just to kind of put things in context. So I'll add those in there, and then the scale I want maybe like, let's say so what's the context? A set of average city temperatures. Okay, so let's say I want maybe I want my set to be, I don't know, 500. So 500 city temperatures, and then just one column. So they are in, 500 in one column, and then I'll just copy this and put that in here, and I'll just do the mean times 3, the standard deviation times 2. As to why I'm doing that, I have to research more into that, but that's how I learned it. And then I'll first of all have to import matplotlib in order to plot this. So import matplotlib.pyplot as plt. And then I'll do plt.scatter to make a scatter plot, x values, y values, and then run that, and hopefully it works. Oh, I forgot to run it, now it's connecting. But either way, what I should see is like a bunch of data points, 500, oh, there we go, 500 data points centered around the mean, which is 23.5. And so this kind of represents the average city temperatures in July or whatever, that are normally distributed with the mean of 23.5 degrees Celsius and a standard deviation of 2 degrees Celsius. And the average temperature, oh, well, that doesn't really matter, but yeah, that's kind of the idea. So this is me kind of just trying to generate a set that might represent that problem, because they're saying a set of average city temperatures, but they don't say how many. And so I'm just kind of guessing. I'm not guessing, I'm just saying, okay, 500. I'm just making like an example. So this is kind of that. And then if I want to make it pretty, by pretty I mean if I want to make it better, I just use the word pretty. Okay, anyway, I can do plt.title and then say average city temperatures. That wouldn't make sense. There's like only 30 though. Let's see. What if I do 30? Either 31 or 30 temperatures in July. That doesn't make sense. So let me do 500, and then instead of like the context of July, I'll do like in a year. So average city temperatures in a year. Does that make sense? Average city temperatures in a year. What would that look like? So average city temperatures in a year. Or I could just change the context a bit and be like average train use in July, or average, what else could be something that I can quantify? Average water use, maybe, or electricity use. And then, no, that wouldn't make sense for 23.5. Maybe average hours spent watching TV. Maybe average, let's see, average TV hours I could do. TV hours in July. Average TV hours in July. Sure. Let's pretend that makes sense. And then, yeah, that's kind of it. Now, as to what the x-axes and what the y-axes are, that's interesting. So average TV hours in July, um, and they're just data points. So I'm questioning what really are the x values and the y values because that's something that I still need to like learn. Like, okay, I understand I'm getting like a random sample from a normal distribution, but like, what am I plotting? Like, what am I looking at? I understand that visually makes sense because it's the data points are scattered around the mean, but like, what am I really looking at? Like, what is this? Because if it's a normal distribution, I would only need one set of points and then like the density. So, and this is essentially the same thing. And if I don't have this, then it's an issue because plt.scatter has to take in two things, x values and y values. So my x values would be what? I wonder. Let me just look at x values and then let me look at y values. So if I go all the way to the top, my x values, wait, hold on, can I do like 0? There we go. Okay, so I'll do x value 0 and then I'll do y values 0. And so these are the basic points that are plotting. So the first one is at 23 and it plots all the way to 76. So that's kind of right about here. That's the first data point. But like, what does it represent actually? Like, what are the x values? What are the y values? And why does it seem to center around the mean? Like, that's interesting. Well, really, this is what actually is centered around the mean. Most of the x values should be near 23, but then the y values are kind of just scattered. They don't have to necessarily be near 23 at all. That's why it's like, 76, because it's the height. As long as they're kind of in between like 20 and like 26, it's kind of like reasonable. And then the height really doesn't matter. But that's interesting. And the height is determined by this. What if I had like just me, what if I had the same thing? Wouldn't it just be the same thing, but in ah, that's interesting. Wouldn't it be the same thing but in a different axes? Like, is it just like literally the same thing but just different axes and just put together? Because if I were to take, let's say, the x values and I were to do import seaborn as SNS and then SNS dot his plot and then just plot the x values, let me see. Right, so it would have like a histogram and it would be centered around 23 point whatever. So that's just one set, and that particularly makes sense for like the number of TV hours. So like, hold up, this could be PLT dot. No, I don't really want to do that right now. But either way, that's what I'm trying to understand. Like, why do I need two? I understand that I need 2 points, like two, not 2 points, but two list of values or arrays, in order to plot this scatter plot. But really, what is this? Like, where am I getting this from? It's the same thing. Like, is it just a random, is it even like how does it make sense? I'm trying to figure this out. Um, because I only need one array for Seaborn, and the X values is the one that makes sense. So, just trying to play around with things. So really, what am I generating? So right here, I'm generating just an array of random values with the loc being what it is and the scale being what it is. And those are my random values. But then in order to have a scatter plot, I'm doing two of them, and they're plotting. Does this even matter? Like, the mean? Like, why is this even a thing? Like, and why does it not matter what I use? So the mean times 3 and the standard deviation times 2. So that's interesting. Wouldn't it be the same thing in both axes is what I'm trying to figure out. Um, because right now I know for sure that the x-axes are the average TV values. Like I'm trying to hours, excuse me. I'm trying to put this in context so I maybe understand this. So then what is the y? Like what is that? What am I measuring there? Or am I not measuring anything that's just there to kind of show a scatter plot here? Is that even possible? Like scatter plot of normally distributed dis oh my god data. I can't spell. Oh my god. Okay. Alright, so how do you tell if a scatter plot is normally distributed? Means that you have a normally distributed data. If the line is skewed to the left or right, means you do not have normally distributed data. What? But that's not a what? A straight diagonal line means you have normally distributed data. If the line is skewed to the left or to the right, it means you do not have normally distributed data. That's interesting. Normal probability plot does your data, blah blah blah. How about this one? Interesting. So let us talk a little bit about how to evaluate whether a distribution is nearly normal or not. Here's a histogram, a normal probability plot of a sample of 100 male heights. Okay. Theoretical quantities, like what does that even mean? All right, for the normal probability plot on a normal blah blah blah, data are plotted on the y-axis. The theoretical quantities follow as a normal distribution on the x-axis. What does that even mean? What? If there is a one-to-one relationship between the data and the theoretical quantities, and the data follow a nearly normal distribution. Since a one-to-one relationship would appear as a straight line on a scatter plot, the closer the points are to a perfect straight line, the most confident we can be that the data follow the normal model. Constructing a normal probability plot requires calculating percentiles and corresponding z-scores for each observation, which is tedious. Therefore, we generally rely on software when making these plots. What is this even? Alright, hold up. Okay, but like, that's definitely not what I got here. I know there's this thing called a residual plot, so it's SNS dot. Is it resid or residual? I don't even know. Could do x values and see if that works. If not, I'll try to play around. Resid. How do you even say it? Resid? Oh my god, let me just search it up. Residual plot seaboard. Oh, resid plot. Is that not what I said? No, it's not right. Where's my stuff? Resid plot. Oh, it's because okay. Oh, it's because these are not okay. First of all, let me do x values dot to list because they're an array right now. And then from there, I'll actually just rewrite them. So x values, set that to that. And then after that, I'll just do x values as type and then do int, not int, they're float. So I'll do float and then or like overwrite them. And let's see if that works. List object has no attributes as type. Of course it doesn't. X values as type. So it's X values. How do I do a for loop? No. It would have to be, let me do a pandas data frame. So data is equal to pd dot data frame. And what is going on? Okay. Data frame. What is literally going on with my keyboard? Okay, data frame, and then my X would be my x values. PD, of course. Okay, because I clearly forget to import anything that I use. What is going on? All right. Let's see. List object has no attribute, blah, blah, blah. So it's going to end up being x. X, it's not data, it's data x, lowercase. And now it's going to be data x equal to data x. All right, so let me reload everything again and run and now see what's happening. Setting an array element with a sequence. Why is that an issue? So data x values, because now it's a list. But if I look at the data, let me go back. All right, it has brackets. Oh, that's why I forgot. Okay. So I have to get rid of the brackets, so that's great. So maybe, so let's see, let me see. I have to put it as to a string first. And then after doing that, I have to do data x is equal to data x. Nope, that's not what I meant. X dot string dot as dot string dot replace the brackets with nothing. And then do that same thing for the other one. So this one here, and then actually I only need two because it's only one. And then I'll just play it from the beginning. Play it, I mean run it from the beginning. Alright, and then this works, and then this still doesn't work. So let me look at the data now. Let me run it from the beginning again. Alright, so now it's numeric data. But then, why can't I plot it here? Unsupported operand types for float and non-type. Are you serious? But I could do a his plot, can I not? His plot and then data. Oh, wait, what did I have before? Oh, that's why. Okay, let me do data x. Run that. Loop of unfunc does not support. Okay, because I forgot to do as type again. So now it's going to be data x and to convert it back to a string. It's going to be data x and then do as type. Set that to float. So let me go back, run that. Now what? Okay, still saying the same weird thing. So then let me see if I could do SNS dot hisplot and then do data x. That works. So why doesn't this work? Does it not take floats? What are you doing there? Get out. Okay. Let's see. What? That's great. All right. Type float and predicted rating is none type as what? Forgot to add return. You can also use no. When writing below blah blah blah, you should initiate your variable a to 0 instead of none. No. No, no. Now, since it has float before none type in the error in math.py is a float itself, this means that perm2d was never defined or is equal to nothing, hence none type declare blah blah, like an integer or float to prevent an error. For example, other variable return No. What do you mean? I literally told it to be a float. Um, so as type float, unsupported operand types for float and none type. Like, what do you want me to do? Like, oh, that's great, isn't it? I don't know. What was I even trying to get to do? I don't even know what I was trying to do. Oh yeah, because the residual plot reminded me of the scatter plot, and so I was thinking this looks more like slightly more like a residual plot than an, and it is a scatter plot, like duh, but the result that I'm getting, which is like scattered around the mean, is giving like residual plot. And this is not helping. Like, so it's ordered response and then normal statistic medians. I wonder. So like what actually is this? It's the histogram and then what? Theoretical normal distribution in such a way that the point should form an approximate straight lines, departure from the straight line indicate departures from normality, blah blah blah. But then what exactly am I plotting? Like what? Okay. Okay. 100 values, the mean is 5, and the average deviation is 1. The value should be mostly within 5 and never further than 1. And then the scatter plot. What in the world? So a scatter plot shows that each value in data collection. So then why in the world did I have 2? Like, what in the world? Wait, but why do they have 2? It just doesn't make sense. A scatter plot shows that each value in data collection is represented with dots. The matplotlib module includes a technique for drawing scatterplots. It requires 2 arrays of the same size and 1 array that contains the values for the x-axis. No doubt, but what are they actually? Are you serious right now? But like, where does this come from? Like, is this like, what is it? Like, what is this? Y-axis? Hello? All right, well, you lost me there. Don't even know how to navigate this site. Um, Exactly. Random data distributions. For machine learning, the data sets can include thousands or even millions of data points. There is a chance that you don't have real life data to use when trying to test an algorithm, so you might need to use randomly generated values. The NumPy model can assist us in accomplishing this. Let's make 2 arrays of 1,500 random numbers from a data distribution. In the first one, you will be, yes, it's finally explaining. Actually, it's not. It's literally, oh my God. In the first one, will be a, what? You will be a set. You will be set with the mean of 3 with an average deviation of 1. The second array will be set with a mean 8 with an average deviation of 2. What does this mean, bro? Okay, yes, I can see that, but like, why? Like, why do I have to have two? I understand the reason to have two sets when it comes to plotting, but like, what is the significance of like, where does this come from? Like, why 8? Why 2? Like, it doesn't make sense. Where are you getting these values from? Like, times 2, that doesn't even make sense. 2 arrays of 1,500 random numbers from a data distribution. So it's scatter plot, and this is a random data distribution, so it's not a scatter plot. Right, so what I have here is not a scatter plot, it's a random data distribution. That's why I was like, I'm definitely not getting that straight line. But if I were to have that, but that doesn't make sense because that's the scatter. It's the same, it's literally the same thing. Like, what's the difference? This is a random, it is a scatter plot. Like, what am I saying? It's just that the other one seems to be, what's the difference? Okay, Each value in data collection is represented with dots. Two arrays of the same size and one array that contains. Oh, I don't even know. See the residual plot. Is that what I'm looking at right now? Is that the residual plot? Nah. The problem with histograms. No. No. The normal probability plot of the residuals is approximately linear, supporting the condition that the error terms are normally distributed. Um, no. I'll graph the same datasets in the histograms above, but use normal probability plots instead. For this type of graph, the best approach is the fat pencil test. If you place an imaginary fat pencil over the straight distribution fit line, does it cover the data points? Blah, blah, blah. Probability plot of non-normal. Okay, so normal distribution plot versus scatter plot. Like Python explanation. Like I need an explanation. I have an array of random integers for which I have calculated the mean and standard deviation. Next, I have an array of random numbers within the normal distribution. I want to plot now a scatter plot of the normal distribution array using matplotlib. Can you please help? What is a histogram of the normal distribution? The closest thing you can do to visualize your distribution of when the output is doing scatter where your x and y are the same. This way you can see more accumulation of data in the high probability areas. That's the thing. That is the thing. Why do they have to be the same? Like what? I just don't understand. I don't understand the logic behind them being the same. Like, okay, but what are the axes? That's what I want to understand. Scatter plot in Python. No. Right, well, this makes sense. The price and then the sales per day. So if the price is 250 and then I see the sales per day is 34. Oh, this is kind of reminding me of linear regression. So there's a negative correlation between sales per day and the price. So if the price is high, sales per day is low. Sales per day is high. The price is low. That makes sense. Comparing PLT dot scatter. That will allow you to create various different line or marker plots. Blah blah blah. No, I don't want to customize. I want the science behind it. Alright, so let me continue just browsing the internet until I find something. So this is a scatter plot. Oh, this is exactly the same thing. For example, let's create a scatter plot where x and y are a list of random numbers between 1 and 100. Give randomized x and y data. The scatter plot looks something like this. Um, okay. This example uses NumPy to generate random data from a normal distribution. Let's create two lists filled with 100 numbers picked from the normal distribution. Let's create a scatter plot from the randomized data. So the x is from a normal distribution where the mean is 2. But why though, bro? Why? They don't ever explain. Okay, this means we expect to see the x values centered, no duh, and y values around 8, but why though? But why? I'm not understanding where this comes into play. The y data, so they're different things. Are they just like two different normal distributions? The y data is from a normal distribution where the mean is 8 and the standard deviation is 3. Today you learn how to produce a scatter plot in Python. No. These are all good. It's close to what I want, but not exactly what I need. Oh no. No, no, no. Um percentile plots. Oh, so is that what it is? No. Probability plots. No. Okay, so just to make sense of the situation, if I were to only have these points, then the y would all be 0. So they would all just be 0. So they need like a y-axis point in order for them to be somewhere on the plot. And that's where these random numbers come in. And so essentially, that's our points. But then how would I use that in like a histogram? Or is it just like absolutely random data? Like it has nothing to do with a histogram? Because I could just, what's the point of me getting normally distributed data? Like, okay, I'm like all over the place. Hold up. So, like, use case of generating normally distributed data. In Python. Why do we need normally distributed data? The normal distribution is the most importantly probability distribution exists because many continuous data in nature and psychology displays this bell-shaped curve when compiled and graphed. What are the applications? Um, we can write the probability density function of variable x as follows. Is a form presenting data by arranging the probability distribution of each value in the data. So most values remain around the mean value, making the arrangement symmetric. We use various functions in NumPy library to mathematically calculate the values for normal distribution. So is it, okay, hold on. So when what if Let me go back. These are not the density values though. What if they were though? Does normal has like a .pdf function? No, that would have made sense though. What is an example of normally distributed data? How they are distributed, so their shape, their outliers, their center, the variability. How do you generate data from a normal distribution? What would even be the point? Why would I want to generate data from a normal distribution? If data is normally distributed, what happens if data is not normally distributed? Um, Choose a mean and standard deviation. Generate a normally distributed random variable. Choose a sample size. Let me look at Excel. Maybe just get away from like this pandas or Python point of view. All right. You can then copy this, blah, blah, blah. Okay, so got it. Generate a normally distributed random variable. Next, we'll use the following to generate a signal, blah, blah, blah. Choose a sample size for the normal distribution. Huh. The end result is a normally distributed data set with a mean of 0, standard deviation of 1, and a sample size of 20. You can quickly generate a brand new data set that follows a normal distribution by simply... Oh! Oh! Okay, so by doing this just one time... Okay, so let me go back down here and get rid of this. Alright, so let me add a line break here and go here. So if I just import numpy as np, and then I do my x, actually let me just do my values and then do np.random.normal with a mean of 50 and a standard deviation of 1 and then a size of 1,000. Actually, let's just do 100 values, one column. And then if I run that, that's going to end up looking something like this. Oops. Why does it keep doing that? Whatever. All right, and that gives me that, which is fine. And then I can do SNS dot hisplot values. Right. So this is just giving me literally normally distributed data, like 100 points of normally distributed data with a mean of 50 and a standard deviation of 1. And so that is how I that's how I create a random normal distribution. And so the scatter plot was just like an extension of what I needed. And then another way I can get the curve for this is if I wanted to plot the curve for this, I could do x values, y values. X values would be, well, that is if I did from scipy dot stats import norm, and then I did norm dot no, this would be np.lens. Actually, wouldn't I just do values here? No, that wouldn't make sense. Then what would be the y values there? So I could do norm.pdf, and then it would be the x values with a log of 50 and a scale of 1. And then these would end up being, let's see, wouldn't they just be the values of hill t dot plot, x values, y values? I would have to go down here though. Whoops. That's so weird. It takes in the values. That's so weird. So then in order to do this, I would do np dot linspace, because they're not ordered because they're random. So it would be np dot linspace, and then then I would start with, but I don't have the variables. It would be mean minus 3 times standard deviation, and then I would just have to say over here that my mean is 50, my standard deviation is 1, then this would be mean plus 3 times standard deviation, and then the size would be 100, and then it would give me a normal distributed curve, which represents this. Oh, so this is a way to generate the normal curve, but this is the way to generate the histogram. Interesting. But then it's not the same though. The x values are just randomly generated, and they start, there's 100 values of these. How could I do, hold up, SNS KDE, or is it just lot kind KDE? I don't even remember what it is. KD. If using scalar values, you must pass an index. Right. It's because the values are not. There we go. Whatever. I'm trying to figure this out. Like, what are the relationships between these graphs? Hmm. I kid you not, I don't even know. This graph is a normal curve, and these are not random values. These are literally 100 numbers, but they're like in order. While over here, these are random values. And that's what's being plotted here though. But it's weird, both of them, it's so interesting. Both of them are Is it not the same thing? But this one goes to 40, this one goes to 20. It calculates a probability density function of these. Does it even matter? Are these the same thing as my question? That's what I want to know. But then when it comes to the scatter plot, why do I need like other generated like data? That just doesn't make sense. Hmm. Okay, so essentially over here, I am creating a normal distribution and I'm plotting the points, but because the x values start like 3 times the standard deviation before the mean and 3 times the standard deviation after the mean and have 100 points in between, the values are in order. And then the probability density function of these values, given that the mean is 50 and the scale is 1, is being calculated to create the standard, not the standard, this normal distribution, given the mean and the standard deviation. While over here, I'm just creating literally just the values, random values, and then for some reason, oh, it's how much they come up. Is there even a relationship between these two? These is like the frequency of what's being plotted in the histogram is the frequency of how many times these random values come up, given that there's like 100. And it happens to be that they're normally distributed with at a mean of 50 and standard deviation is 1. So the frequency of these values, most of them are going to be near 50. Interesting. But then over here, linspace is ordered numbers, and that's why it's giving me this over here. What if I were to do ELT dot scatter, which is what I tried to do the other day, and it gave me a straight line, but it's like not a straight line, it's a curved line, which is so weird. Like, I don't even know. Anyway, that's enough for today. I honestly just want to go right now. All right, I'm gonna go. I'm gonna continue trying to explore, maybe read some articles. But yeah, that's it for today. Bye.